Hello. I believe you may have actually a break right now, but I'm going to go ahead and record this lesson because I think you'll enjoy it, and we want to kind of get here because it's an important thing. So if you don't see it the same week that I record it, it's okay with me. All right, so what we've done so far, I looked over your parse trees are looking good. You learned how to build an executor for the most basic kinds of commands, but right now we can only do linear processing. So, assignment really is about all we can do. And so now we need to have control structures. It's not really programming if we don't have conditions and branches and loops and so on. So let's take a look at how we would build these sorts of things. So the first thing we'll look at is the sorts of control structures you may see. Now, Pascal has a particularly rich set of control structures, and again, it depends on what language you're trying to write a compiler for, but these are reasonably typical. And so the kinds of statements we'll see, first of all, the compound statement, we already understand the compound statement, right? You'll see that most of the control statements are a special version of the compound statement. Allows us to have, allows us to have a lot of things. We'll also have a thing called a constant, which is related to what we've seen before, so a value, and a constant list, which is a list of contents. That'll especially be helpful when we handle case statements. So you got compound statements, which we've done. We have assignment statements, which we've done. Now here's kind of the new ones. We'll have the while. As a Java programmer, you've used while quite a bit. There's also another variant of while called repeat. This is available in Java, but we don't use it very often. It's like a while statement, but the condition happens at the end, and the condition is, it's a little different. I'll show you when we get there. The for loop, which is a very common mechanism in programming languages. The version of it in Pascal is a little different than what you may have done in Java. I think Java's solution is a little more truthful, if Pascal's is a little easier to read for beginners. The if statement, of course, you know the if statement. And this one, the case, which is a select statement, I have de-emphasized the use of this in Java and C++ because they can be very problematic. But we will go over how they work, and as you see how this type of structure is parsed, you can see why I have misgivings about it. But we'll do it. So let's take a look again at the basic statements in BNF format. So the while statement says, while some expression is true, then do a statement. Of course, the statement is typically a compound statement, but we don't care. It's a statement. If the statement happens to be compound and contain a bunch of others, great. If that contains other kinds of loops, great. We don't care. As far as we're concerned here, it's a single statement. Okay, that's great. And then when the statement, eventually somehow we keep coming back here, eventually when the expression is false, we go to the next thing. The repeat is almost the same, except the order is different and the expression is different. So in a while loop, you continue the while loop as long as the expression is true, and the test comes at the beginning. In a repeat structure, and in, I believe in Java, it's do while. I don't use it often. Repeat statement list, your test comes at the very end, so it's guaranteed to happen one time, and the value of the expression is different. In the while loop, as long as the expression is true, you stay in the loop. In the repeat statement, as soon as the expression becomes true, you get out. So you stay in when the expression is false, you leave when the expression is true. Logically, they can be identical, so it really doesn't matter. You never have to have this one, which is why I didn't emphasize it in Java. Because if you can do this, you can make it do this, pretty much. Okay, so the for loop, you're used to a for loop, right? The way we did for loop in, say, Java or C, C++, even Python, well, now Python's for loop is different, is for, and then it had three pieces, right? You have a I gets 0, so you have some sort of a counter. It starts out at 0. I is less than 10, so some sort of a condition or expression, and then I plus plus, somehow you change that value. Well, the way it's done in Pascal actually is reminiscent of BASIC. It actually makes it more abstract. It would say, for I gets 10 or 1 to 10, do something. Okay, that's a little more elegant. For I gets 10 down to 1, do something. Okay, that's fine. That's fine. It's still doing the same thing. And as you see, when we create the parser for this, it's going to look like the one you've done in Java. The if statement is quite straightforward for the most part. If an expression is true, then do statement. We will also check for an else, which is optional. If the statement expression was false, then we do the second statement. For now, we're not going to do else ifs, but they actually aren't that difficult. They would just be under here. Now, the case structure is kind of complicated. Case expression, so you have an expression, and then it could be one of a number of values. So if it is this, if it's, let's say we have case I of 1, do this. Case I of 2, do this. Case I of 5, do this. You can also have a list of possible things it can be equal to. So case I of 1, 3, 5, that's a constant list here. Then do this. The reason we didn't really emphasize it is that it causes a lot of problems if it's not used well. And most of the time, when you have a select or a case structure, you're often better off using something like a function or a list. And so I don't really get too excited about it, but it'll be interesting to see how we actually create a parser for this thing. Okay, so those are those basic expressions we'll have. All right, so let's move along. Error recovery. Okay, we're not going to get super detailed into the error recovery, except to note that it can be a very complicated thing when we start having loops and branches. And you know this as a programmer, right? Is that things get pretty ugly if you make a mistake in a loop. If you make a mistake in an assignment or something, okay, fine. The computer knows what to do next. But if you're writing a loop and you have some sort of a mistake in a loop, you can have an endless loop. The compiler can easily get very, very confused. And so it's also quite possible that the compiler doesn't know what to do. And often the compiler could not know what to do forever. And that can be a real problem. So generally what happens is when you find a syntax error, you just terminate. Well, programmers, compiler designers like that. It's easy. But programmers don't like it because I don't know what went wrong. So that's not that helpful. Then you can try hard to spit stuff out, but a lot of times when your compiler finds itself confused, even things that would normally make sense don't make sense to it because it's stuck in a parse tree somewhere and it's not expecting things. What you'll often see done, and you can read this over to get more information, but what is normally done is what's called synchronization. And so what happens when the compiler gets lost is it just keeps eating tokens until it finds something that it can process. So it can say, waiting and waiting and waiting until I see some sort of an end loop. Okay, when I know that I'm at the end of a compound structure, all right, I can just ignore everything in that structure and try to move on. That's called synchronization. And they do it here in the book, and you can take a look at it. But I'm not going to get too focused on that because it is quite an advanced topic and it's pretty tricky to get right. We're not going to worry too much about that. I want to get on to how do we create parse trees for these various conditional structures. So it's nice. It feels a little awkward here. Okay. Syntax checking doesn't really change that much, so I'm going to skip that too. Here's where it gets fun. All right, so we have these various parsers, and remember we've done these parsers before for our other kinds of statements. And so the statement parser is already an abstract class, and we implement it to get the various kinds of things. We've already done an expression parser. Now we're just going to add a few new parsers, and they will always return an intermediate code node like we've done before. So this is nothing too shocking. And there's the source code of it. Again, this isn't really that big a deal. What it's doing is it's taking a look at the current token and trying to figure out which kind of parser we need based on a current token. So if we have a begin token, you know we have to build a compound statement parser. If we see a repeat, we're going to be creating a repeat statement parser. You're way ahead of me. While statement parser, for statement parser, if case. If it's none of these, get out of Dodge. We're in trouble. Okay, so we're looking for one of these things, and we're going to hopefully be able to build one of them. So then we look at the statement parser, and this is going to handle some of that synchronization. So I'm going to not worry too much about it, except to note here's some things we're looking for. Hey, I see a semicolon. That was maybe the end of a line. Hopefully I can recover after that. Maybe pass a missing semicolon command. You look for an end statement. You look for some kind of a terminator to tell, okay, maybe I can recover after this. All right, let's move. Here's assignment. We've already done that. Next token, we've already done that. This tries to synchronize on an assignment. Let's move along. I'm not that worried about that. Here's where it starts to get fun. Okay, so we have these repeat statement. So the repeat statement, remember, is like a while loop, except it's a little different. So take a look at this code in Pascal. Repeat, J gets I, K gets I, until I is less than or equal to J. Yuck, I kind of hate that. What do I hate about that? Well, I don't know what I doesn't change, J changes. And so it's a little bit scary, but okay, repeat until, so this is the code that happens inside the loop. Here is the condition. The condition is tested at the end of the loop, and if the condition is false, you stay in the loop. If the condition is true, you get out. Think of it this way. Repeat, eating cereal until I am full. If the condition I am full is false, I stay in the loop. When the condition I am full is true, I get out of the loop. All right? The while loop version of that is while I am still hungry, stay in the loop. If the condition is true, I stay in the loop. I test it first. And then eventually I test I am hungry is not true anymore. I get out of the loop. Does that make sense? So, okay, the repeat has a condition that exits when it is true, and the condition is at the end. So you look at it, it's actually easier to see it in the parse tree. So the loop is essentially a form of a compound condition. And what will it have? Well, here's the body of the loop. And then at the end of it, you have a special test node. And the test node then takes a comparison operator and values. So most of the times the test is either a Boolean value or some kind of comparison operator. So test I is less than J is what that's looking for there. Does that make sense? Yeah, that actually makes a lot of sense. So there is that loop. And that will continue until this test is true. Okay, compare that. Here is the code for it, and you can see once you understand the parse tree, the code is pretty straightforward. There is the XML that would generate. And once again, we can see the XML is just another way of saying the parse tree. I think the diagrams are actually easier. Let's take a look at a while loop. It's a slightly different approach. So while I is greater than J, do K gets I. Okay, and again, sometimes we would have a begin and structure in here. There would be a compound. I prefer that, but that's the way it is. The reason that the while loop doesn't necessarily require an explicit compound is it is already compound, because it already has some structure at the beginning and some structure at the end. So we can tell in a repeat when it ends. While you can't tell when it ends without an explicit do structure or begin structure. So let's take a look at the while. So loop, remember in a while loop, the condition is tested at the beginning. So also in a while loop, if the condition is true, we stay in the loop. If the condition is false, we get out. So the first thing we do is this test, and that actually negates the condition. We'll test for not greater than. If it's not greater than, then we do the stuff in the compound assign. In this case, it's not compound, it's simply one line. Or it could be compound. You do all of that stuff, and then you come back and test. And then when the opposite of this condition is true, you get out. Okay, so that makes sense. There's the parse tree. There is the code to actually consume that and create the subnodes that we would need. And given this Pascal code, there is the XML we would get, which is just another variation of that parse tree. So being able to read the XML is really key because it helps you understand the parse tree. Okay, when you're doing while statements, you have to be careful about syntax errors. You have to be careful to see if things are going wrong. That is illegal in Pascal. You have to do the comparison first. So it should catch that. Now let's take a look at for loops. For loops are old friends, but as you look at them, they can be kind of complex. So here is a for loop in Pascal. For k gets j to 5, do n gets k. So this is going to happen depending on what j started out with, maybe 5 times. K is the century, it's going to change, and we're going to keep assigning k to n. All right, we don't really care. What we care about is how does that turn into a parse tree? Well, it's kind of complex. So a for loop is a compound structure. It's going to have a body here. Right now it's one line, or it could be another compound. Then the loop structure itself is its own tree, and that tree generally has this shape, although its variations can be different. And here's where, as a Java programmer, you actually have an advantage, because in Java and C++, we would say something like I gets 0, I is less than 10, I plus plus. Well, that's what the loop structures do, and that's why the C-like languages set it up that way, because it actually is very close to the way the parse tree would be built underneath. So in a loop, the first thing you do when you get in a loop is you test to see the condition. So you test to see if the condition is true. Remember, in a for loop, when the condition is true, you get out. Okay, so I check to see, is I greater than 10? Okay, then I will assign. I'll do some work. This actually is the initialization, I think. No, that's the code. Okay, so let's see. I hate the way they did that. Okay, that is actually the body of the loop. Yuck, I don't like that. Okay, and there is the assignment. There's the initialization. So here's the initialization. I'm sorry, that's not the body, that's the body. So here's the initialization. There's a test, there's the body of the loop, there's an assignment statement. So we initialize once. Every pass through the loop, we test to see if the ending condition is true. We do the body of the loop, which could be a single statement or a compound statement, and then we do the change the century. You remember I used to teach you how look at the century variable. How does it start? How does it end? How does it change? That's the same thing that's happening inside the parse tree, right? How does it start as this piece? How does it end as this piece? How does it change is that piece? And so we're adding 1 to the counter usually, although it could be other things, right? And since Pascal has its to and down to techniques, that would automatically convert to an add 1 or subtract 1. But that's basically what's happening here. So that is essentially what a for loop does. And again, you can look and see the parse turns out to be not too complex because all it's doing is, as usual, producing the appropriate nodes. And that, for now, will create the XML parser, and then we'll turn that into an executor in the next session. But once you do the parse tree, the executors are pretty easy. So here would be a for loop, right? For k gets j to 5, do n gets k. There's a down to, there's a more standard one. For I gets 1 to 2, do begin. So that begins this compound statement in the center. And we have a nested loop. Can we do that? Sure, we can. You can imagine the parse tree for this is going to get pretty complex. But that's fine. We understand how it works, and it really doesn't matter that it is complicated. As you look, there's the parse tree, and the nested loop, as we expected, gets a pretty complex parse tree. But that skill of being able to draw out a parse tree, that is invaluable. Understanding what's going on there is really what you need to be able to do. If you do it as an image, or if you do it as XML, doesn't matter that much. But understanding that that's what's happening, that's when you truly are understanding how programs work. Okay, so syntax handling is usually about getting this wrong. So Pascal uses the assignment : equal as an assignment operator. That is an easy thing to forget because in our other languages don't do that. Okay, if statements. Let's talk about if statements. If condition, then do something, else do something else. So we have a condition expression. All right, so the if statement says first thing I gotta have is an condition expression, and then in the standard case I will have at least one then block. And I may also have an else block. Turns out it's not too complicated. So if comes up with a test, this is going to be an equality test, we check to see. Now it doesn't have to be, right? If I is less than 5 or something, right? So some sort of a test happens, and then we have two bodies. This is the body to do if things are true, if the condition turned out to be true. In this case, it's a single statement, but it could be a compound, a complex compound structure. And then if the condition turned out to be false, then we can have we have another expression. And that expression, again, can be a single statement or it can be a compound statement. And part of the reason we're not dealing with else if and so on is that we can actually nest ifs, right? So, and we can put them one after the other. So it turns out that with a standard if, you can get all the behavior of the others. In fact, you can also, with a standard if, get the behavior of a case structure, which is why I'm not too uptight about it. Okay, so when we do an if statement, the parse tree is just going to have potentially 3 branches. This else if just is cascading. And so the else if is not a separate structure. Really, in Pascal, it just nests an if inside an else. Yeah, okay. Some languages do it a little bit differently, but this is how Pascal does it. Some languages have a totally separate command. So Python has elif. So it does it slightly differently, but honestly, it doesn't matter. And you can see that these Else ifs are simply embedded inside the original if, so it's really not a big deal. All right, let's see. If statements, the biggest issue with if statements, and this would explain something you sometimes see, is when you put a semicolon at the end of an if statement. Remember, the if statement is expecting some sort of expression to do. If you put a semicolon, and this is true in almost any language, at the end of an if statement, then it assumes that that expression that you're supposed to execute is empty. And so the next line of code that was meant to happen only if the condition is true will always happen. The condition is basically ignored. And you can see why the semicolon would tell the compiler, hey, we're at the end of the expression, when we are not. So that's pretty important. Pascal requires the use of the then keyword. When you think about Java and C++ and so on, we use braces for the same behavior. I like the Java approach. It's a little more consistent. So braces surround everything, where that's not true in Pascal. All right, the case statement. It's easy to get all tied up in the case statement. We're not going to get too uptight about it because it's not something I recommend you use that often. In Java, you have what's called the switch. That's also in C++. In the basic-like languages, it was called select case. In Pascal, it's called case. And it works pretty much the same in each of these languages. So case, then you have some sort of expression. And then the of keyword, now we have a constant list. So we're going to say if, this is essentially like saying if I plus 1 is equal to 1, then do this. If it's equal to 4, do this. If I plus 1 is equal to any of these things, do that. Now on the surface, this seems absolutely wonderful. And how cool is that? That's a really nice way of going. And you're right, it is pretty cool. It has some problems. One of the problems is the syntax, especially in the C-derived languages, is very awkward. And in the C-derived languages, figuring out how you end one case is awkward, and you end up having to use a lot of break statements. I just don't like that. As you'll see, the parse tree for this is a bit ugly. And Java has one more problem in that these expressions can only be primitives. So they can only be characters or integers. Well, if you're forcing them to already just be integers, you might as well use them as indices of an array, honestly. So I find it actually unnecessary in Java. And that's okay. We'll look at it anyway. It's a neat structure, and you'll see it sometimes in other languages. So here is the parse tree for that monster. That little structure becomes this parse tree. What? Okay. So select, the first thing we're going to look for is our value. Now, usually it's not an expression. Usually it's just a variable name. But fine, whatever. So select the variable name or value, and then you have these select branches. So each of these things is a select branch. Select branch is going to then have two sections generally. It's going to have a constant, and then it's going to have statements. Those statements in this case are simple assignments. They could be compound, they could be whatever you want. So here's basically how this is going. So we take I plus 1, and then we compare that against 1. If that's true, we do this assignment, we do this code, whatever it is. Then, now it's not always clear. Different languages have different behavior. Would you just leave automatically? Well, in Pascal, once one of these is true, you get out. In the C-like languages, unless you explicitly tell you to get out, it then looks at all the others as well. Confusing. Yeah. So let's just say this was false. It wasn't equal to 1. We come down and we check the next one is equal to 4. If it's equal to 4, we do this. Now this last branch is a compound constant. So now we're looking to see if this value is equal to this or this or this. And if any of those is true, then we do this structure here. Oh, yeah. Again, it's not super difficult, but it is a little more complex. And you got to be careful. And we'll see different languages have slightly different edge behavior based on how they work. And in the C-like languages, you have to explicitly use a break statement, and I've never been a fan of those. And it's never really necessary. Python doesn't even have a switch structure, and I've never missed it, honestly. Okay, so this is basically how that works. The errors you can see are sort of the standard ones. Did I not end something? Did I not use a proper compound structure? Then managing the compound constants is a little trickier. So you can see we're just going to move along and see how that parser would work. Let's see. Here is some case structures. There's that one that we looked at, and you could see there's the intermediate code it would create, this XML tree. So, as always, it's about understanding how those particular values work and creating the appropriate parse tree. All right, that's good. Do we have any more today? Yeah, that's going to be next time. We'll take a look at how we interpret these control statements, which, as you learned last time, is relatively easy. Once you know how to parse the various kinds of structures, then actually creating executors, or in this case compilers eventually, turns out to not be that difficult, because a compiler is just an executive in assembly language. That's all. All right, you are amazing. Keep up the great work. I feel like you're learning a ton. It's time for us to start getting ready for the final. So we'll be working on that final project. All right, or a final exam. I don't think we'll do a project here. All right, you're amazing. Take care, and I will see you soon.